All right, I'm just going to start. Oh, wow, that's really loud. I'm not a very loud person, so when I'm that loud, it's really strange. Okay, I'm just going to get into this. Is that really loud for everyone? Just me? No? Okay. So we're going to talk about avoiding the OWASP top 10 and what those are and how you can. I'm going to talk about what each one is, what an example of failure looks like, and some general ideas or some specific things about how you can not get owned. Oh, really? You're going to do this? Okay, there we go. So, a little bit, I don't know how to use my computer. I am an illustrator turned developer. I went to school for painting and drawing, and turns out you can't make money doing that. Yeah, I worked in a coffee shop for a year, and I hated it, so I decided I'd get a real job, and I became a developer. I'm very, very thankful that you don't need professional certificates to become a developer, because then I would go back to school and all that jazz. Anyways, it's worked out pretty well. So I've been a PHP developer for about 8 years. I currently work at a company called FreshBooks. We do online invoicing and accounting as a software as a service. So you can, if you have a small business, you can send invoices, accept online payments, all that jazz. I also work on Cake PHP, which I talked about yesterday. Today's talk is about neither my work or my open source work, but both of them are involved with security, so that's why I'm going to be talking about it. So security is a complex and ever-changing topic. What was good security practices 5 years ago will probably get you in trouble now. Security is also tightly related to a lot of standards like PCI and HIPAA and all these other types of things, which are designed to, they're like policy frameworks for making decisions around security. And security goes well beyond just an app stack, like an application security. It goes all the way down through all layers of your infrastructure, through your hardware, through networking. If you're dealing with PCI as like a service provider, like a level 1 service provider, you have to have physical security. You have to have guest registrations, like secure rooms where people handle cardholder data. So security is a really complex topic, and we're only going to be talking about software today. And another really important thing to remember with security is that it's a continuum. And sometimes you have to make conscious choices between security and non-security. My favorite example of the security continuum is a door. So at the end of this room, we have a glass door that you can easily just punch a hole through and walk right through. So that's great for this room. Might not be so good on the front of your house. It's probably a really bad idea on a bank or a vault filled with personal information, right? And so the same thing applies to computers. So you have basic web security, so you'll have password hashing and all of that, and you might have really strong symmetric encryption, but if you're just storing, people's pictures of their cats, you're probably not going to symmetrically encrypt those photos because it's not that important. No one's going to come by and forcibly break in and steal all your cat pictures and leave. So you have to always keep in mind, security is also often a balance between usability and security. When you make a system ultimately secure, like a bank vault door, getting into your house on a timed bank vault door where you could only push a button, wait 10 minutes, open the door, but it only opens between daylight hours is pretty terrible on a house. And by the same token, you don't want to use two-factor authentication to go and post pictures on Twitter or post photos of your kid. I don't know, maybe that's the wrong balance to make. But you have to make those decisions consciously. If you just haphazardly fall into those decisions or make them without knowing, you've probably made the wrong decision. And so it's always good to think about security, where the trade-offs are, what trade-offs you're willing to take, and what risks you're willing to take. Because when you trade off better security for ease of use, you have to keep in mind that you might be trading off something that could kind of burn you down the road, and just make that trade-off consciously, because otherwise you'll get in trouble. So the OWASP it's a big acronym that stands for Open Web Application Security Project, and what they do is they provide a number of tools for developers to use, for web developers specifically, and those tools range from a whole bunch of stuff, from the top 10 list that I'm going to be talking about, to a bunch of penetration tools like Burp and WebScarab, which are really, I don't know if they make Burp, but they definitely make WebScarab. which are tools that you can use to do additional security work. So WebScarab lets you record sets of HTTP requests and then replay them, and lets you programmatically change the inputs and just do this sequence of steps, but try and do SQL injection attacks on everything. Now try cross-site scripting attacks on everything. Those are two things we're going to be talking about. But today we're going to be talking about the top 10, and this list gets updated every so often. They just released one in 2013, which is this year. Not back there, it's this year. The previous one came out in 2010, and so what the list is, it's the most common and most critical and most easy to fix vulnerabilities that happen in web software. And most of them have very straightforward solutions and very straightforward causes. There are no magic solutions. Most of them just require some thinking and a little bit of work. And yeah, the most important thing is knowing what they are, because just like in G.I. Joe, knowing is half the battle. I don't know if G.I. Joe exists here. Yeah? All right. They probably didn't have the knowing is half the battle. It's probably in Spanish. I don't know what that is. Because I only know 10 words of Spanish. So I'm going to be spending more time on the ones that are directly solvable in PHP and less time on deployment-related ones, because those are harder for me to talk about because I don't know what your system looks like, and they're always different. So we're going to look at spend the most time on the ones on PHP and generally glaze over the ones that are deployment-related, because it's mostly just knowing what to do and looking how those kind of problems apply to your infrastructure. All of them might not apply to your system. This doesn't mean that they're not important, they just might not apply. You always have to think about risk management. So the first one, and the best one, is injection. It used to be called SQL injection, but they've generalized it because people made more mistakes. So there are two main types of injection. The best one is, and the most widely known one, is SQL injection, which is hilarious when it happens. The other one is command injection, which is also even more hilarious because it's probably going to go down to a lower level of the system. Basically what happens is bad guys can run arbitrary code or arbitrary SQL on your computer. So it's basically just giving them a shell or a terminal or database access and just letting them do whatever they want. So this is always number one because it's the worst. So SQL injection, we're going to have some basic SQL. So we're going to take some data out of the post, and we've got a query. And then right here, we're just going to put those values right into the query. It should already be making you itchy. And then we're just going to run it against the database, because these are going to be fine. So until someone does this, and they go, my username is root, my password is single quote, or whatever, 1 = 1, which is true, SQL comment, and then keep going. And then your really great SQL query, you just interpolated all the values, turns into this, where the password is empty string. It's probably not going to be empty string. Or it's this giant string. And you may think, well, I'll just hash the password, and then they won't be able to do that. Haha, Mark, you're dumb. But they'll be able to do it on the username. And so the thing with SQL injection is password hashing will save you from the password field, but it won't solve you in a general use case. And also, let's say you're taking someone's bio, they're uploading their name and their description, their URL, and you miss one of those, then you're hosed. So don't do this ever. Wrong. What you should be doing instead is using an ORM or some sort of database abstraction layer. Pretty much every framework on the earth comes with one of these. If it doesn't, you've chosen the wrong framework or the wrong ORM. Just start over. So yeah, Zentable does it, KPHP does it, Lithium has it. This is a huge part of Doctrine, obviously. Pretty much every tool does this. If you're just using MySQL query or MySQLi query or just PDO without doing the prepared statement part, you're doing it wrong. You should change your code because someone will come by and just do this. There's also automated tools to help you find these types of things, so you can use WebScarab, and there's other tools like Nessus, which will just run across your site and just try and blow up everything. So the main rules of thumb for SQL injection is never, ever, ever interpolate user data into a query. Just never do it. Never, ever, ever use regular expressions or magic quotes or add slashes or any of that silly stuff. What you should do instead is always use prepared statements. And the way prepared statements work is you put placeholders. You can either use question marks, or in PDO you can use colon and then a word. And that's a named parameter. And then when you prepare a query, this is all using PDO. You prepare a query, you get basically a prepared statement, then you bind the values in, and once you bound the values, what happens is this gets sent to the database server as one piece, and this gets sent to the database server as a second piece, and then the database server puts them together, and it doesn't make mistakes, because really bad things would happen if the database made mistakes. So then we execute the query, and we get the results. And this totally protects us against pretty much all the SQL injection attacks that can happen. Yeah. One other thing is some people will remember that MySQL query will only execute one query at a time, and you'll think you're safe if someone just starts dropping semicolons in. PDO does not do that. It will run all of the SQL queries. So if you've ever relied on that as a mitigation, don't do that. So command injection is another fun one. This is when people just send you arbitrary data, and you put it into systems operations like reading files, running shell commands. Those are probably the two worst ones that I can think of right now. Just don't ever put user content and just rip stuff off the file system, because someone will do this. And they'll just keep adding more and more dots until they find etc password. Etc password is not really a valuable file on most Linux distros anymore, but it's a good proof of, it's always there on most Linux distros, so it's a good proof of concept to see that you can find other bad things. And once you find etc password, then you can start trying looking for other common OS things, and you can figure out what distro they're on. Then you can find where their web server password is. Then you can get their SSL private key. And so getting etc password is like, oh, well, you got a file that doesn't do anything. Whatever. But it shows an attacker that they've got something valuable, and they can just keep looking. And if you're asleep and it's 2 a.m., they'll just write a shell script. They probably won't even have to write it. They'll just download it off the internet. And something that just keeps walking around looking for files until they find a file that they want, that's valuable. And if they get something valuable, then you're kind of in trouble. So the easiest way to get around this is to escape your input. Surprise, just like a SQL. Look for double dot, and the URL encoded versions of these, and the hex ones, and all of the various encodings of double dot, because double dot enables file traversal, like you can just walk around the file system. So that's bad. Semicolon's also bad if you are crazy and taking user input and putting it into like exec or system calls. Semicolon's a great way to just add some extra commands in, like rmrf. Like my name's Mark, semicolon rmrf / see what happens. Maybe they're running the web server as root, that'd be dumb. So if you're ever handling file paths, always use real path on the file first, and then make sure it exists inside a directory sandbox. So if you're uploading files or reading files off the file system, make sure they're always in, it's a subtree of a known file path. So if it's not, it doesn't go outside of your uploads folder, or it doesn't go out into the system directory. That's what you really want to do. And if you are doing shell commands, make sure you use this. It's called escape shellarg, yeah, I think it's called escape shellarg, which will also sanitize stuff, because spaces do things in Unix, and people have all sorts of fun with that. So the next one, if anyone has any questions at a time, just ask them as well. The next one is broken authentication and session management. That's how you do it, yeah. So the biggest risks here are identity theft, and basically someone can easily masquerade as a second user, and that's probably bad. Firesheep was a good way of this. They worked on slightly different principles, where you would go onto an open Wi-Fi network and just scrape all the cookies of everyone talking, and then you steal their cookies, and now you're them. The internet is stateless, so cookies are valuable. This is why people try and steal them. Firesheep is a good example of that. Another really dangerous attack related to cookies and sessions is session fixation. And this is, you should never ever, again, take any data from the user and use it to make a session ID. Because then what I can do is, like, as an evil person, you can just dictate what someone's session ID is. You can send them a link in their email, say, reset your password, the session ID is this. And then they can have, like a process sitting on their server just waiting, trying that session. Does my session work? Does my session work? Can I log in yet? And they just wait for someone to log in. And then as soon as their script finds that someone's made a valid session with the session ID that they gave you, now they're you. Surprise! And now they can their automated tool will probably just walk around and start doing work. So never let users specify their session ID. Also, don't build code that lets that you decide their session ID. This is also a terrible idea. If you ever see session ID anywhere in any get parameter or any request parameter, just try screwing around. because you probably will be able to do it. PHP has a really bad mode where the session ID goes into the URL. Turn this off. It's off by default. Don't turn it on. It was on for some really goofy reason in the past. That does not make sense anymore. So don't do it. So some good ways to fix this is rotate the session IDs when you log in or when you log out. And anytime you have to change, basically anytime you change privilege levels, you want to rotate the session ID because if someone did get a handle on the session ID, like say they were using Firesheep and because you forgot to use SSL, at least then they only have an unprivileged session ID, and then they'd have to get it again when the person logs in. Obviously, the Firesheep thing is mitigated by using SSL, so that's obviously always a good idea. It's worth the $10 a year to get an SSL cert. Set the HTTP only flag on your cookies, all of your cookies, unless you need them in the client side. Especially on the session cookie, because you probably never need that client side. Yep?
Is the $10 a year version NSA free?
I don't know about the NSA stuff, but yeah, you're probably in big trouble with those guys. So you also want to, like, any cookies that don't need to be client-side, don't let them go client-side. This is like a layered defense system, because if you have a cross-site scripting attack, you don't want someone stealing your session cookies. So just always try and, like, restrict as much things as you can around sessions, because they're really valuable when you can steal one that is connected to something that has money or something of import. Another important thing is to use well-tested libraries for authentication, and always use SSL, because that prevents the Firesheep thing. It prevents people from just going into a coffee shop and listening for HTTP traffic. Oh, look, logins and passwords. That's fine. I'll just take those. Yeah, just be careful. So next up is cross-site scripting attacks. I think this one has been moved down. It was at number 2, now it's at number 3. I think this one got moved down because people have started to wise up to how cross-site scripting works, and a lot of libraries and tools are starting to fix it for you automatically. So the risk of cross-site scripting attack is it allows bad guys to do anything as the person who's looking at the web page. So let's take a banking site. You log into your banking site. If there's a cross-site scripting attack, someone could send you a link that does like a reflected cross-site scripting attack, and then they can do things as you. They can run the code on your computer, because your browser is so nice. It'll just run the code on your computer, do things as you, but you won't know. And so it's really good for stealing credit cards, passwords, hijacking people's accounts, just reset their password, change the password to something else, kick them out. Now you know the password because you stole it. It's really good for those types of things. It's also really good for doing denial of service attacks. Facebook had like a virus of this where you saw a thing on the wall and then it would post another thing to your wall and it would send to your friends. Your friends would see it, they'd be like, oh, that's dumb. And it would post to their wall, and then MySpace had one as well, and it took down MySpace. So it's not just that people will steal stuff. They could, if you don't have anything worth stealing, someone might just be a jerk and just try and take you down. So this is how you do cross-site scripting. Oh no, you just lost. You lost at the internet. You might be thinking, I know, I can use regular expressions and take out all the angle brackets. That'll stop them. So no, don't ever do that. Just don't. It's horrible. Script tags and regular expressions are not an effective defense against cross-site scripting attacks. I would hazard to not ever try and remove HTML out of user content. Again, the OWASP site has a really good, I think it used to live on hackers.org, and so now it's on OWASP, and it's a list of all of the common ways you can do cross-site scripting attacks. And I think there's about 65 different ways that you can do cross-site scripting attacks with various encodings. You can try UTF-7. UTF-7 is a really fun one because the angle brackets are offset by 1 byte. So if you use a regular expression, it misses it because your regular expression is in ISO or in UTF-8, but they use UTF-7, which shifts it over 1 byte. But it still gets output on the page as the other byte, so it's good times. Good times. So just don't use regular expressions. The best way to solve this is to escape the output. And so that's the safest way, is always just convert the user data into the correct encoded output, and also always specify the character set that matches your character set. What this does is it helps obliterate any shenanigans with UTF-7. So if people are trying to pull tricks on you with UTF-7, this kind of stomps them out, which is nice. The only problem with this is it's a pain in the butt. Manually encoding is really error prone, and you will make a mistake. You will. I have. I was like, I could do this, no problem. I'll manually escape everything. I've screwed it up so many times, I just gave up. Instead, what I would suggest you do is use a templating library that takes care of this for you. So Twig, Smarty 3 does it now. These are all much better tools if you're using any other libraries or languages. Usually stuff like Jinja and the templates in Rails, they all handle this for you. Just use them. Just don't turn the encoding. You always have to opt out of escaping, so just be really conscious of when you opt out of escaping, that you have entered the danger zone, and just make sure that that never has user content in it. One of the dangers with encoding is that the encoding is dependent on the context, and there are like 5 different contexts in the web. There's HTML, HTML attributes, URLs, CSS, and JavaScript 5. And every single one of them has a different encoding rule. So you have to be very good. If you are interpolating user data into CSS, there's different rules. If you're encoding it into a URL, there's different rules. And all of the encoding rules are not compatible with each other. So you have to be really careful. And so when you're escaping things, make sure you use the right escape for the right context. Another really important thing I think to do is when you're doing HTML attributes is always use double quotes, because spaces will end an attribute in HTML5 and let you add new attributes in. So a really fun one to do is to send on mouse, like send double quote and then on mouse over. So if you're not doing the HTML attribute escaping correctly, you can just add extra attributes and you've got more cross-site scripting. So yeah, be careful, use good libraries, or be smart and just don't output user content. That's hard though, because that's the whole point of the internet. So the next one is insecure direct object reference. This sounds really complicated, but it's not. Bad guys can basically access information that they shouldn't, and bad guys can modify data that they shouldn't. Just because people can't see what you've tried to hide from them doesn't mean they won't try. People will try and request things based on guesses. They'll just try and add stuff into the URL, see if they can get stuff. Anytime there's a number in a URL or in a form, don't rely on that being hidden. Hidden inputs are not hidden, basically. Hidden inputs are only hidden to like grandmas and our parents. It's true. Hidden inputs are not hidden to people who are going to try and, they're not hidden to developers. Like you can just look in your browser and Chrome will say, these are all the post variables. Well, it's not very well hidden. And so don't rely on hidden things staying hidden. Always do proper checks. Always make sure that people are modifying things that they should be allowed to. Like if you're handling money, make sure they're not just going to say withdraw money from, take money out of Nate's account, put it into my account. It should be like take money out of my account, put it into Nate's account, but we just want to steal. So really sorry to poke at the GitHub guys, but GitHub had a problem with this with the SSH keys. They had a user ID in the form, and someone, a guy, just changed the user ID and started changing people's SSH keys. Thankfully, GitHub is awesome, and they fixed it in like an hour after finding out about it. So these are the types of things where you shouldn't rely on hidden forms staying hidden. Also, another important thing is don't rely on things not being in the form, not being in the form. If you have database attributes that aren't in the form, someone might just try and add them in. So don't just take all of the requests and just go splat, stick that in the database, because someone might just put some random shit in there. Or they might just guess at what your schema is. If you're using a framework that has conventions, or you're using a framework that dictates how your database should be designed, or if you've exposed data somewhere else, like if you printed out a user ID, someone might just try and stick it in a form and just change it and see what happens, right? Like, what's the worst thing that could happen? They'll say no. Or it'll work, and yes. So always validate not only the content of your inputs, but what inputs you're getting. Another really fun thing to do in PHP is take, because it'll automatically accept arrays. This is a problem we had in Cake, actually, with our authentication system, which is pretty lulz. You could take the username and just turn it into an array, and it would screw up. So that's another fun thing to look out for, is make sure that the data you have matches the data you expect. This is also really important if you're using object relational, like document stores, like MongoDB. If you take user data and put it into a query, it might not be a string. Some jerk might just change it into an array and add all these extra fun Mongo operators. So be careful. Yeah, hidden inputs are not hidden. validate access to everything. So if people are trying to modify a document or read a document or read some data in your database, make sure that they can. This means you just have to write code. There's no easy solution for this like the previous ones. You just have to write code. If you need to refer to the current user, always use session data or some sort of data that doesn't come from the user. So if you want to like modify a user's friends or modify something that belongs to the user, get the data out of the session, which isn't data they gave you. Also whitelist properties. So most frameworks have now switched the defaults to accept everything to accept nothing, and you have to whitelist everything. And that's a much safer way to do things. Basically, all users are trying to kill you and eat your brains. So don't trust them, because they're all evil. Well, most of them aren't, but assume that some of them are. Another good one is, the next one up is security misconfiguration. And so default settings on some pieces of software are not secure, and they're intended for development because most times, I don't know about you guys, but when I have to change file permissions, I don't change them to the correct thing, I just change them to 077 because I'm on a development machine and I don't care. This is not how you should do things in production, obviously. A lot of a lot of tools and libraries will come set up in developer mode versus in production mode, and so you have to be aware of that. Especially, yeah, you have to be aware of that because it might not come with safe defaults. It might come with fast defaults or easy to use defaults, but not safe ones. Attackers will try and figure out, if they know what software you're running, they can try and see if you've misconfigured anything. PHP is a great example of this. They have URL fopen on. It used to be on by default, now it's off. And it was great because you could send people files. If they accepted a file, you could say, just read this URL, and it would just go and download crap off the internet. Not so good. Safe mode is another one. Magic quotes, session IDs and the URLs. These are all bad defaults that would easily fall under misconfigured security settings. So the easiest way to solve this is to know all of your tools. Know every piece of code that you're running, like know every library. It's not easy, yeah. I said easy, but it's not. Also keep up to date on the vulnerabilities of the tools you use. And remove and disable any services or features you're not using. So if you've just got a new server and it's running a whole bunch of junk you're not using, like let's say it's running a queue server but you're not using it, just shut it off. If it comes with 2 web servers, shut one of them off. Because software that's not running is not going to have any problems. Well, in theory. And if you're not using features of your framework or your ORM, just delete them. Code that doesn't exist can't cause security problems unless you need that code there to stop a security problem. It's hard to give specific information when you don't know what people are doing. So sensitive data exposure, that's a credit card number. That's one of the test credit card numbers for Stripe. So if you need to test credit cards, that's a good one. So the risks with this is people can get information that they shouldn't. So most applications will have some sort of sensitive information or something valuable in them because you're probably making money and there's probably something of value in your application. Otherwise, how does it, I don't know how it works. So depending on what the sensitive information is, the consequences differ. At my job, I mostly deal with credit cards. And basically the problem is, the issue is there if you get cardholder data taken from you and you don't have your PCI validation and you didn't follow all the steps, your company ceases to exist because the card brands all sue you for infinity $billion. And that's the end of your company. Everyone loses their job. It's different with different government regulations. Yeah. So you have to assess the risk that you have. You have to start off with, do you have any sensitive data? Do you have any data where there is a commercial cartel or a government institution that will care if this data gets leaked? Do you have social insurance numbers? Do you have credit cards? Do you have people's health records? Do you have, I don't know, passport numbers? Like, these are all important things that people don't want to have stolen from them. If you have pictures of cats, are any of them really important pictures of cats? I don't know. The next thing to check is it in plain text? Are you at any point in time outputting people's passwords in plain text? Do you have like API keys to other people's services? Are you outputting those in plain text? Because then if you had a cross-site scripting attack, someone can steal them. So those are the types of things. You want to go and like always approach security from like a belts and suspenders things, right? Like if your belt breaks, at least you got suspenders. If your suspender breaks, at least you got a belt. So your pants stay on. If it isn't in plain text, is there any old or bad crypto in use? Are you using MD5 to hash some of your passwords? That might not be a good idea because you can rainbow table MD5 passwords in about 0 seconds now. Do you have any broken crypto? Like, are you using any really old ciphers that are really easy to crack on people's graphics cards or a phone? Are you missing SSL anywhere? Like, does your login form not have SSL by accident? Can you get to your login form without SSL? Those are the types of things you want to look at. The other thing is, depending on the regulations you have to follow, you may have restrictions about who can access sensitive data and key rotation systems. So you have to look at those types of things when evaluating your problems here. Yeah, don't screw around with card brands. That's all I gotta say. They are not nice people. Another good one is number 7 is missing function level access control. And so what this is if your functions of the public functions of your web application are missing access controls, random people will just come by and request stuff. Maybe not right now, maybe later, but eventually someone will figure this out and they'll just come by and just randomly make requests like, let's see if I can delete all of the comments on this post. Yay, it worked. Those are the types of things you want to mitigate and like not have happen. Yeah, so at FreshBooks we once, like 5 years ago, we had a fun one where you could just request anyone to delete any other person's file if you knew the number. Except they were all auto-incrementing, so you just guess. Like, you know what yours is, guess what the next one is. See what happens. Oh, it didn't delete from my account. Sucker. So those are the types of things you want to watch out for. Any place where there's an auto-incrementing number anywhere in a URL or a form, just make sure the access checks are correct. That bug has been long fixed, by the way. It's not still there. Another good thing to check is mixing of access levels. At least at FreshBooks, we have multiple levels of users who can do different things. And it's not just a matter of a missing access level check. It could be an incorrect level check or an incorrect access control check. So if you are supposed to, you don't want to just make sure that the user's logged in. You want to make sure that the user's logged in, they're allowed to see what they're supposed to be. Are they the right role of user? Does this thing that they want to look at or destroy, does it belong to them? Those are the types of things I usually look for. Unfortunately, yeah, there's no simple solutions. Good automated tests will help with this if you have the ability to have a big automated suite. So good, like a WebDriver-based tools suite or something with Jerkin or some sort of automated full stack integration suite. This is a good place to try and automate those types of things. Those types of tests are really slow, but they're valuable to just make sure that the whole system is sane. And a tool like WebScarab is really good for finding the auto-increment type things because it'll look for URLs that like query string parameters or post parameters that take numbers, and then just try incrementing them, decrementing them, and like other fun things to do is like send max in, try and get like overflows. If they only accept like a certain number of characters in the field, just send like 10 megabytes. That's a fun one for passwords as well. If they do use a strong hashing, just send them like 100 megabytes for a password and just see what happens. And then just do it like 1,000 times in a second. That's a fun one to do. If they are using something like bcrypt and they didn't put a max length on how much they're going to accept, you can just get their server to spend 10 hours hashing your passwords, and you can suck up all of the resources on their system. So those are the types of things I like to. Sounds really horrible. Those are the things I like to look for. Just like serious screwing about, like. Yeah, if they take a number, what happens if you send them like, 128 bytes of numbers? Like, does it just fall over? Do you get to have fun bonus rounds? That's how you find out. The next one is cross-site request forgery. I don't know why this one's moved down to number 8. I think it's a really important one. So the risks with cross-site request forgery, also sometimes the C gets turned into an X for cross. So the idea here is that an evil website can perform actions on your website when people are logged into your site, which sounds confusing. Side effects on GET make this even more bad. Hopefully everyone here knows that you should never do side effects on GET, so you shouldn't be able to use a GET request, like an HTTP GET request, to delete things or update things. Because there's a really fun, we'll get into it, it's fun. There was an example of this type of problem was Gmail a couple years ago had a problem where you could just get anyone's contacts if they were logged into Gmail just by asking for the correct URL. Just be like, give me all the contacts. Gmail will be like, sure, here you go. Well, thanks, Gmail, you jerk. So the way a CSRF attack works, so you have your application and then the evil site and a hapless user. So a hapless user logs into your site, or they're logged in all of the time, like I am for some of my sites. What happens is they accidentally get sent to an evil site because the evil site sent them an email saying, your password needs to be reset. Your account has been suspended. And, you know, your mom gets it, or your dad, and they're like, oh man, my account's been suspended, I better click this link. And so they click the link, and because they didn't know they're not supposed to do that. And then the evil site submits a form. So they go to, you know, fake PayPal. Fake PayPal sees that they're logged into, just randomly does a random HTTP request to real PayPal, just to see if it can take some money. If they happen to be logged into PayPal, and PayPal had screwed up the CSRF, they would then be able to do a request. Because HTTP, again, is stateless, and it doesn't know where the request is coming from. It just says, oh, someone asked me to delete some money. Sure, delete some money. It doesn't know that the request came from PayPal. They don't know that the previous page that the person was looking at was on PayPal. And so what you want to do is always ensure that the request did come from you, and that's how you protect against cross-site request forgery. HTTP headers, especially the refer, is always, that's user data, don't trust it, it's full of lies. If you do trust the refer header, someone will just send it with the correct referral header and make it look like it came from your site, but it didn't. So the way that you solve this is by adding opaque expiring tokens to all forms. A lot of frameworks will either implement this, a request that's missing a token or has an invalid token should be rejected. So if you do a request to delete some money and you don't have a matching request token, then the request should not be fulfilled because you don't know where it came from. It could just be anyone's request. Yeah, don't accept random requests off the internet. You don't know where they've been. So this is a really simple example. So if the post data doesn't contain a CSRF field that matches one that we have in the database for this account, this person, then we're just going to throw an exception and do it. A lot of frameworks often put it in a cookie so that they wouldn't be an evil site. So if we go back, the evil site wouldn't have access to your site's cookies. So if you put the CSRF token in the cookie, this site can't read the cookie, and so they can't send it. They can't read the cookie, so they can't send it back to you. So then it'll never match because the request will come from the person's browser, but their browser will have the cookie, so it will send the cookie to your site, and then you'll get a token mismatch. Another good way to do it is stick it in like a cache, like Memcache or Redis, and then always just give people new tokens, and then when someone sends you a form request, make sure the token matches the one you wrote down in your database or in their cookies, and that's a good way to make sure that you don't get hosed. Using components with known vulnerabilities, also known as the common vulnerability exploit database bingo. Using old busted software can expose you to issues. Security researchers will often report these issues and to the projects will fix them. And then to get security researcher to get some notoriety in the security community, people will report those to common vulnerability exploit databases. And what these are used for is to build tools to build automated attacks, attack tools for penetration testers. So they don't have to go through all the boring stuff. They can just use a tool that, like Nessus, that would just go through and try and do every commonly known attack on the software that you have. So CVE databases are full of exploits and version numbers. If you happen to expose a version number to an attacker, like if you're, by default, Apache will say, this request was fulfilled by Apache 1.2 and PHP 5.0. And you're like, yes. So you just take the version numbers, you go to CVE, you put the version numbers in the search field, you push enter, and it says, these things will break if you do these types of requests. And the nice thing is the CVE database even has all of the sample, like the attacks on how to do it, or suggestions on how to do it. And so what you want to do is not be one of those people that can be attacked by that. Large CMS projects have lots of problems. They're complicated pieces of software. Any large complicated piece of software will have a number of exploits. And so what you want to do is make sure you stay current with your software. Keep up to date with everything as best you can, and make sure you read mailing lists, watch out for security advisories, and just try and stay safe. If you can't upgrade, take your version numbers, go through the CVE databases, and look for problems, and then either manually patch them or fix them. The nice thing about the CVE databases is they often have links to like which versions were affected, what version it was patched in. Then you can go to the project, find the release that they've fixed the problem in, and most projects will have some sort of responsible disclosure where they'll say, you know, this patch fixes these security issues. Please apply it. So yeah, it's pretty basic stuff, but this is where the database is. It's fun to go there and look for stuff that you've written, or stuff that you use, and just see what can go wrong. There's a few databases. There's one, this is the English language one. There's also one in Japan that I don't have the URL for. The content is all in Japanese, but Google Translate is really good for finding what actually went wrong. Package managers like Ubuntu has a security releases section. Most of those are really easy. You just go into like aptitude and just push enter on all of those and just install them. Make sure you do some testing before you do all of that in production. But yeah, like just keep up to date on your security exploit, like your security vulnerabilities, and you'll probably be okay on these. Number 10 is unvalidated redirects and forwards. This is, again, don't trust users because they're all evil. Basically, the idea here is like, have you ever built a login form that has a redirect to page? Like you go request, I want to see my dashboard, but you're not logged in, so it sends you to the login page. And then when you log in, we take the data from the query string and then redirect you back to that page. And so what you want to do is make sure that page exists on your domain. Not on, just don't accept random URLs and send your users to those random URLs, because they could be phishing sites. So say you have a login form that someone can send an email to just a bunch of people and say the redirect URL is to evilsite.com/your company or whatever. When the user logs in, it'll send them to your site because your code is very diligently sending them off to the place they've requested. That site could be a phishing site, and then the person will be like, oh, my login didn't work. That's okay. I'll just type it again. Derp. That's not really their failure. That's yours because you built crappy software. Not you, but the person who built this built crappy software. And the problems here are that you can have a breach of trust with your users. They're trusting you to do the right thing and keep them safe. And so when you fail that, you kind of fail your users. The easiest way to fix this is don't trust user data. If you do have that redirect to, just chop the domain name off. That's the easiest way to do it. Like, just take the whole host name, just throw that all away because that's clearly garbage. You just want to send them onto your site, chop the host names off, and just put yours on front, and then redirect them to that host name. That's actually the easiest way to solve this. And yeah, that's pretty much all I got. So thank you.